Alright, I made a long-winded version of this. I'm going to do a real short and sweet one now, just in case I really don't like that other one. Anyway, I took a rod. It's roughly 1/4 inch. It's not precision or anything like that. I cut a point to it on the lathe there. The runout's pretty good. It wobbles a little bit, but it doesn't matter as long as I'm not rotating that. I don't care. Now, what I have is a Datsun 411 spindle in here, okay? And I want to modify my disc brake bracket. I noticed I did it several years ago, and I've learned a lot of things since then, how to measure better and that kind of stuff, get more accuracy. And I noticed some of the dimensions were off, so I'd like to redo that and get everything better. Okay. Now it's really easy to measure the distance between the holes and get that spacing and get the diameter of this boss and the spindle in here and the height and everything. What's hard to measure is, features like this. How far out is that point right there, and how low is it from this machined surface? Okay. So what I've done is I've taken this rod, I found center of this hole, and I put that at 0, 0 on my DRO. Okay. I went over here and to this hole and made sure that it was lined up this way. Okay, had to do that a couple times, jockey it around a little bit. They're both on the same plane now, and I know these are across from each other too. So anyway, these were 60. These turned out to be a hair over 80. Kind of weird. This is in millimeters. So then what I did was I could now come out here and put the pointer right down on the edge there, which I've already done. Like I said, this is the short and sweet version, just to give you an idea what we're talking about here. So I bring the tip down to where it just touches but doesn't deflect. Okay, so I put the point over that, and my DRO told me how far from the center line I was out. Okay, and then I was like, okay, great, and that's the last of my 0 on the z-axis. Okay, well then I came out, that was at 18 millimeters out. Then I came out to 20 and touched off and took a z reading. And then I came out to 25 and touched off and did a Z reading, and 30 and 35 and 40 and 45. And I'm out at 45 now. And the goal I was shooting for was to be, this is 3/8 plate, hot rolled pickle and oiled. It is 9.4 roughly thick. Okay, and since my 3/8 inch brackets sit bolt to that, they're 3/8 inch thick, I want to know how far out I have to be to get clearance here. Okay, lift this up out of the way here. So with that there, how far in can I go here? And I'll be able to plug these into CAD, and then I'll know that I got to be at least 40 millimeters out to get 9.85 millimeters down from this surface. Okay, that'll clear the 9.4. Won't clear it greatly, but as long as I'm over 40 millimeters from that edge there, or 58 millimeters from that line on the holes there, I can put the 3/8 inch plate, anywhere in here, kind of thing. I just can't go in closer than that. So I'll probably do the same thing back here. I can also, knowing the diameter of this, I can touch off on the sides and get dimensions and measurements and positions and that stuff of the other features. I could actually measure the bottom of these pockets, and how far out they are from the center hole there. They taper off at about the same rate, so I just need to know how much further down they are at the same distance out. But I can plot all that stuff. Depends on just how much detail I want as to how close I make those measurements. 5 millimeters apart, 10 millimeters apart, 1 millimeter apart, so as to how many times I touch down. I don't want to make a grid on here 1 millimeter square and touch down on every point, because that's just overkill, especially for what I'm doing. So instead of having, that's what the digitizing probes do. They do these 3 dimensions in space when you have it referenced. I'm doing it the slow manual way, basically. I don't need to know how long this rod is, because once I touch it down on here, I'm using this as my 0 plane. Okay, so then I'll have negative numbers going this way, and I'll have positive numbers coming up this way. All of this stuff above it, I'll just measure that with the calipers. That's a piece of cake. So, I think that's about it. I'm referenced to the backside. That backside of those 3 holes there is machined for the steering arm. So I think I'll go plot a few more points, but I've already recorded most of what I needed. And I'll show you this real quick. I've just got a real rough sketch here. I kick the camera every time, don't I? I've got it upside down. I wasn't paying attention when I bolted it in. I should have put it the other way. But anyway, there's my rod thickness. There's the radius, so I could subtract it at the time. Here's my z-axis going down. And that's from that center line on the holes, 20, 25, 30, 35, 40, 45 out from that mark. So I can do another grid going the other direction to find out how wide these pieces are and all that kind of stuff. So that's what I'm playing with. Next thing up will be to finish these dimensions, take that, go back to the CAD, model this in CAD real quick so that I can then use that to modify my bracket. Bigger machine would have done it. I should have mounted this thing longitudinally this way, because this is as far as I can go. I can't get the part back any further, so that puts me out about 50 millimeters, which is, I still got another halfway, another 50, 60 to go here in order to read that. So I'm not going to worry about it too much. I've got a lot of other projects I want to do, and this gets me close enough for what I'm trying to do. I think the rest of the measurements I can take off the machine. I've got some milling I want to do, and I figured, well, I'll whip out a few more measurements on here and get them jotted down and that stuff, and then I can go ahead and take this off and not have to worry about mounting it up again. So that's probably what I'm going to do. But anyway, make sure you got your full range of motion there before you get started.